Thanks again for coming over. So the rough structure of the presentation is 30 minutes or so. We'll go through a sequence of 4 different topics. So first topic, we will cover kind of the business aspect of this presentation. What does affinity answer mean? What's the business benefit that our end clients receive? Then we'll transition into the technology side. So we'll start with the data. So Mahesh will talk about the data side, where we source the data, how we organize it and whatnot. Then Shawn will talk about how we model the data and do predictions based on the data for ad targeting. And then I'll come back again and then give you guys a quick peek on the visualization. How are we presenting the data for our clients to get the benefits? So that's the rough agenda for the meeting. So what's the key problem that we solve? A business problem that we solve is for any brand, any consumer brand, media brand, entertainment brand, how can we actually leverage the social affinity to extend audience reach? Every brand has a challenge of finding enough audience. How can I find enough audience to reach in a very targeted way? Let me go to the next slide and then explain to you the problem in more detail. The classic problem in advertising is as you expand reach, your relevance starts to drop dramatically. And this is not a linear relationship, it is more an exponential decay. So it's very easy to get the first, say, 10 percentile of the audience. As you go down and then start to try to get the 50th percentile, 60th, 70th and 80th, it becomes very, very hard to have your reach, your audience be performing at the same level that you had at the beginning of the range. So that is the classic problem in advertising. And this is nothing specific to digital. It's a historic problem always. So what is new? What we believe is with social affinity for the first time, you can actually change the nature of the graph. And obviously the difference, the incremental difference here is very material to make a significant impact for any advertising company or any company involved in advertising. So where is that affinity coming from? So this is one of the models of a classic consumer funnel. There is awareness, and then there is interest or affinity, and then there is intent, and then purchase. Historically, any ad targeting starting from direct mail of the 60s and 70s and 80s and so on, starting from there, a lot of people had purchase data. Purchase data was always available at a lot of scale with retail point of sale scanners and whatnot. Then once the search became available, intent data started to become available at scale, though it was monetized far better by fewer companies, Google being the top dog in this industry. Along with that, in display advertising, you also started to get cookie data. So if I went to cars.com or expedia.com and I tried to configure a travel going to, say, Cancun and using, say, Delta Airlines, then I have an intent to buy a Delta ticket to Cancun. And then thereby I could be targeted as a cookie. I could be targeted elsewhere if I did not complete the transaction to come back and then buy the Delta ticket. So the intent, again, data became available about 10 years ago, and that definitely kind of expanded the way to target. The challenge with purchase targeting is if you wanted to, let's say, you take any advertiser. So let's say I am selling a Toyota Prius. I probably need to sell 50,000 units a year, but I may have a very low purchase conversion from my ad targeting efforts, 0.1%, 0.01%. So I need millions of people to be able to convert, but I only know there are only 50,000 people buying the car every year. How do I get to 10 million people? So the classic approach here is, let me go and then target the broadest way possible. Let me go by 18 to 34 demographic audience, which is historically what was done. And as digital came along, people tried to do, okay, let me go very specific. Who bought the car or who bought a competitor car, say a Volt or something. Let me try to target those people. All of them ended up with having not enough reach. You did not get enough reach. And that is where even the intent data couldn't help. So people tried to target, okay, people are searching for Prius, so I'm going to put a search ad and hope that enough people come and then buy my car. Even that, again, did not give enough scale. So there is the classic problem of I had very high reach, but very low relevance here, and I had very high relevance and very low reach here. So this was a classic trade-off. And affinity, we believe, is the key to solve this problem. It's, again, nothing specific to us, but the way we do it, we believe, is a unique way that actually solves the problem in a very, very effective way. But social affinity is, for the first time, lets you give large-scale audiences who are actually saying, okay, I am interested in a Prius because I'm tweeting about it, hashtagging about it, I'm commenting on Facebook, I'm posting photos of my car on Instagram. So there are all these behaviors. If you're able to publicly aggregate publicly available data, then you are able to build an affinity graph. That affinity graph can extend, for a lack of a better word, the advertising graph and the intent graph. So you can complement those graphs and then build essentially a very scalable reach extension for most of the advertisers. That's essentially what Affinity does, is it captures a very scalable and engaged audience before they have taken action. So that is the, was that a question? Okay. So what does Affinity Answers do? We track the affinities for about 300 million consumers.
Is your affinity only Facebook and Twitter? Or
Facebook, Twitter, and Instagram as of today. As of today, the way we, there are other sources like Pinterest and Tumblr and all those sources. It's a kind of a business choice that we made, that these are the 3 networks that probably cover 99% of the affinities out there. So, is there a follow-on question?
No, I'm
okay.
saying that you're just addressing the social media in the digital world, not necessarily anywhere else, like picking up that data from any other advertising source or something.
So there is we are already actually we are not going to go into that detail in this presentation, but affinity data is where we started with, but we're already starting to aggregate TV ad placement data. So who ran, for example, where are all the ads, Toyota Prius, what are all the shows that it ran ads in the last week? Let's say they ran on CSI New York and Walking Dead. Then you essentially take the fans of CSI New York and Walking Dead and then say, okay, I know they have been exposed to a Prius ad, and thereby they are going to be more responsive to a digital ad. So if I actually can score the online cookies on their propensity to have watched the show, then I actually have the tailwind of them having watched the show. And so instead of targeting a random 18 to 34 audience, right, a very broad 18 to 34 audience, I might still keep the demographic criteria, but I'll actually add a receptivity criteria. And the receptivity is who are the likely people might have watched Walking Dead. Okay, so that is essentially, that is something that we are starting to do, and we are also in the process of actually evaluating and adding search intent graph as well, the intent graph to layer on top of the affinity graph. So the database is about 300 million consumers. Again, it's all publicly available data to be fully compliant on privacy and other things. And then 40,000 brands, consumer brands, media brands, entertainment brands, TV networks, celebrities, sports leagues, a whole gamut of things. So that is essentially the big giant matrix that we are actually tracking on a daily basis, and Mahesh will go into a lot more detail on what does it take to actually track all this data and do the aggregates and then essentially activate the data. We track them over time. Data is really captured on a real-time daily basis and aggregated into our system. This is just a quick screenshot from one of our visualization tools. It's actually showing you the top 10 shows for a brand. It's actually showing for what are the top 10 shows for like NASCAR and Top Gear and so on. But once we go to the product demo, you guys will actually understand it a lot better. So that is the data part, and then what is the algorithm part? And again, Shawn will talk about the guts of the algorithm, but this is giving you kind of the marketing pitch or top level pitch on what this algorithm is. This is again a lot of trial and error. This company is 9.5 years old, and we started with MySpace data and kind of learned that is where we learn what does it mean to be a popular network and not so popular network anymore, and how does that consumer behavior changes when it is actually when people leave. When it actually is initially hot, what are the behaviors? For example, friending was the hottest thing in 2006. In MySpace, everybody wanted to be having a lot of friends. So if I'm a music artist, I wanted to have a lot of friends. In 2008, everybody had 1 million friends. And thereby, friending was no longer a cool thing to do in MySpace. So as we track the behavior over time, we realized that anything, this is the curse of marketing, is any metric that everybody thinks is cool, everybody tries to game the metric. And thereby, the metric is no longer useful. So in this case, friend counts was such a metric. So what we realized was just liking alone is not enough. You got to actually look at, are they putting the music on the player? Are they commenting on the page? So you got to actually look for behaviors rather than just liking. So that led us to when we started tracking, for example, Twitter data, we actually were less concerned about tracking followers, because we knew that a lot of people might just blindly follow a lot of other handles, but they may not be checking the tweets at all regularly. Then what's the point in following, right? So you want to see, did they retweet, reply, So you want to see whether they engage with those active behaviors. So, so from day one, we were tracking all those what we call as active engagement behaviors, but that was not enough. If you actually took the affinities of, say, the Price fans and looked at what are all the affinities they have, what are other brands that they're engaging with, we actually used to call this the Lady Gaga problem. The problem was Lady Gaga is so popular, she would always be on top 10 for every brand. And thereby, it is just reflecting the population. It is nothing unique about the brand. So it is unreasonable for every brand to think that all of us should be sponsoring Lady Gaga. So then we had to actually do a lot of trial and error. So we actually did the opposite of things. Okay, if it is not what my fans like, maybe I should look at the problem upside down on who likes me. In this case, Price, whose brand's fans, where I rank the highest. So that is what we call as a reciprocal affinity as opposed to forward affinity. If you just did reciprocal affinity, it had an opposite problem, what we call as a stalker problem. The stalker problem is you have these tiny audiences that are totally, let's say this is a band whose lifestyle is all about tattoos, and then they will be into these tattoo brands. 80% of them will be tattoo lovers. So if you are a tattoo brand, you not necessarily don't want to go after that audience because it's been saturated already. So thereby you want new audiences, not go kind of preach your message to the same old audience. So if you just did that reciprocal affinity, that was not enough. So then it dawned on us that what you're really looking at is just like a real world relationship. So if the guy likes a girl, that's not enough. The girl has to like the guy to have the relationship. If the girl is just chasing the guy, it's just talking, the guy doesn't want her. So if the guy is only into her and girl is not into her, the relationship is not going to happen. So thereby you want that mutual relationship. So you want to balance both the forward affinity and the reciprocal affinity to come up with mutual affinity. And this is actually one of the key findings of our stuff, of our experiments when we actually built the algorithm over time. And it sure enough performed very well. So you can see a very rough analogy here to the Google PageRank algorithm. The very rough analogy is PageRank obviously said when it came in 99, 2000, it was kind of state of the art because it looked at how many pages linked back to me. So thereby it was kind of who loves me. Similarly here it is which brand's fans love me was a key kind of a concept that goes into finding the, if you're the Nutella fan, then you want to find out is Finding Carter relevant to me? So is there a mutual affinity to that brand? And that helps you surface audiences that are very relevant for your targeting. So it performs very well. So I'm going to cover 2 or 3 business use cases just so you see how they are in action, and then we'll go to the technology side of it. So this is a couple of years old, but nevertheless demonstrates the effect of how to use affinities. So Pepsi came to us and then said, like, look, we are looking to sponsor one of the 4 artists, Nicki Minaj, Katy Perry, Lady Gaga, and Beyonce. Who do you think is the best fit for my business at this time? So we did this affinity analysis. What you see in X and Y axis, this is the affinity score. That's the mutual affinity score. There's a bunch of things that go into the algorithm. Shawn can better answer that. And the reciprocal reach is among each of those artists' audience, who likes Pepsi the most? And you actually see that Nicki Minaj fans like Pepsi the most. So we recommended that they go sponsor Nicki Minaj. So they went ahead and sponsored Nicki about this time. And then you can actually see this is the affinity growth among Nicki fans, among each of the artist fans towards Pepsi. So you can see that the kind of dramatic rise in growth among Nicki fans. Interestingly, a month later, they also sponsored Katy Perry, but the artist had a fallout with the brand. She didn't say, look, I don't want to promote the brand. Even though they had a sponsorship announcement, there was no marketing behind it afterwards. So you can actually see that the Katy Perry, the orange graph is just kind of growing along the rough rate of the population growth, whereas you can see a very statistically significant growth among, it actually went from about 2.5% to almost 5%. So among the audience of Nicki Minaj, it doubled, the affinity growth doubled. And this was a great validation for them to realize like how my sponsorship is working. If you think about it, this is taking social data as a kind of a signal, but as really making business decisions outside social media. That has nothing to do with social media at all. So that is the power of actually using social data for, it's now common knowledge that bunch of market research can be done on social media, but this is just not recruiting people out of social media and asking them a bunch of questions, but just observing sorry, observing their behavior. Right. Next example, it's a lot of tables, but I just want to point out. So this is it's a tiny picture, but this is Rob Dyrdek, who's a host of the show Ridiculousness. It's one of an MTV shows. The classic way that people actually looked at this. So I talked to you about the sponsorship, and I'm going to talk about like Google, how this data was used in Google AdSense. So the classic way, in this case MTV was the client. So how they arrived at is to use Google Ad Planner. So if you use Google Ad Planner, you type in ridiculousness, it is going to tell you people who are searching for ridiculousness are also searching for funny videos, or he had another show called Fantasy Factory. They're also searching for Fantasy Factory and so on. So those would be common things. Obviously, if there are guests in the video, you say, oh, I got to buy those keywords, Johnny Knoxville, Travis Pastrana, and so on. So those are obvious. So these are obvious choices that they essentially went and bought. And this is essentially the volume that you can actually see, how much volume that they could get and the CTR they could get on Google recommended options. Then they said, okay, how can Affinity help? So when we actually suggested to them, these are keywords. As you know, Shawn White is a skateboarder. Shawn has nothing to do with the show itself. He is not featured in the show. The show is not about skateboarding. But Shawn audience were intensely interested in the show. Not only Shawn, there are also Jason Mayhem Miller, Mac Miller, and so on. These guys are actually, they are like hip hop artists, but also their lifestyle is supporting skateboarding. And this is not, it's a kind of a little bit of surprise for them. But when they looked at that, one of the previous lives, Rob was a skateboarder. So thereby, skateboarding audience were very interested in the show, even though the show has nothing to do with skateboarding. And this is an audience that actually was obvious in hindsight, but was not obvious in foresight. And this is an example of relationships that Affinity can uncover that is not always obvious. We'll take a pause here. Any questions? Okay. So I'll hand it over now to Mahesh.
Hey guys. So I'll walk through some of the data and tech stack in terms of some volumes and what we use, and then hand it over to Shawn after that. All right, so this is just some numbers that we have. So the raw data that we get is from these sources, and we have roughly about 50 million interactions. Interaction is could be a tweet, could be a post, could be the comment action on a post. So that's the number of interactions we get per month. Okay. And then we have, what we do is sort of try to get a bit more aggregations on top of it, and that comes to about 300 million users when we look at all of these sources and the 40,000 brands that we actually track real time. And roughly, the brand user associations seems to translate to 1:10, 1:12, sorry. So it's about 3.5 billion brand user associations is what we have. So basically, it's saying, okay, there's a user X who's associated with brand 1, Toyota Prius, Lady Gaga, and so on. So that's the kind of associations we're talking about. That's the number over here. And then what we build finally is, for the 40,000 brands that we want to track, we have a graph which is sort of populated reasonably densely, more than 50%, with saying, for this brand, what are the other brands and what is the mutual affinity ordering for that. Right? So that's what the affinity graph with 40,000 nodes has. And the density of the graph is roughly around 55%, 55 to 60% is what we have today. Okay? All right, so this just sort of writes down some of the challenges that we have. One is about the real-time streaming of the social data itself. And the second one, of course, is more a decision on what queries do we want to serve quickly, what queries can we do it more as a mining thing later, and how do we store them separately, and so on. The third is, of course, the graph database that we have, the Affinity Graph database. And the last one kind of gives you a rough idea of what is the number of metrics we'll need to compute. So if you have 40,000 brands that we track, and we have another 40, it's a 40,000 by 40,000 matrix, then you want to compute some bunch of metrics for each cell in that matrix, right? So that's one. The second one is sort of something that we find very interesting when we go to the research folks in various companies. When I say research, for the market research kind of folks, I'm sorry. So it's not just Toyota Prius and Lady Gaga, but I would like to know, how does Toyota Prius fare against rock music, pop music, and maybe a genre of celebrities which are like athletes. So how do you do that kind of a computation? It's not, this is a more granular one, while this is a coarse segment, a coarse mapping of a bunch of brands which could belong to athletes or which could be part of compact cars. So that roughly we have about 18,000 segments that we sort of work towards. Some examples over here, you have compact cars, animation shows, thriller movies, and so on. So our 40,000 is across multiple verticals, and so that's where you have a sample of them over here. The other thing is, of course, okay, just like you said, you have granular Toyota Prius versus all these coarse segments. What about just coarse versus coarse? I would like to know how do athletes fare against pop and rock, right? So that is another coarse versus coarse mapping. That's another computation that we had to do. And there's a bunch of what we call as custom segments, and this is like somebody coming and saying, oh, I don't want to go with your segmentation of animation movies. I just want it to be like a small set of like 10 movies that I think are most important for us. And I want you to compute the affinities for them. So that's roughly just to give you an idea of what kind of computations we do, okay? So this gives you an overall flow of where we get the data from, what phases do they go through, and then finally how is it served, sometimes offline, sometimes through an application itself. So I'll start from the left. So social data mainly comes from DataSift, which is one of the aggregators of social data, as many of you would probably know. Then we have, of course, our taxonomy of 40,000 brands that we track. And one question about do we do only social? So Teletrax is the company that we do get ad signals from. And as Sree alluded to, we've just sort of started doing it. So that also gets into the whole stream, whole flow actually over here. And we have something more Shawn can talk about, and he will. The classifiers, social data is pretty messy. So finding something relevant and sensible out of it is a pretty large piece, and I think that's one of the phases that we have become good at over time. And then we have some transformation of, okay, let's talk about what kind of data we get from social, right? So you get tweets, and along with the tweet, for people who know what kind of data comes through, you typically get a large JSON or something like that which has a lot of attributes. And some of them may be relevant, some of them may not be relevant for our purposes at this point. We always store all of them so that we can do offline mining. So that is definitely happening. But extracting important pieces and attributes out of it and then making it available for further processing is what this piece does. And you see a combination of a few of Java, Perl, Python, because of sometimes we may have to do go to another source to get some social data, maybe through another provider who says, okay, I can give you some specific data for one of these brands, so can you just take that in? So we've sort of worked some custom stuff over there, okay? So we get most of it into MySQL, and we use, at this point, we have a re-architecture sort of thing going on, so it's like a version 1 to version 2 kind of stuff. So we have SoftLayer, which was one of the, which is now an IBM company, by the way, and we also are looking and seriously investing into AWS. This is the 3.5 billion user brand associations I talked about. That's what the data from the MySQL gets stored into this, and this is sort of like a proprietary system that we've built over time, which will eventually sort of feed into this affinity graph database. This is, again, as I said, the V2 version of what we have, where data flows into AWS, and there's we're exploring Amazon Redshift so that we can see if we can scale with, as always, constraints in terms of how much money we spend and so on, right? So that's the most important thing over there. And there's a lot of processing that happens over here to compute the metrics and then finally produce this for the 40,000 versus 40,000, 40,000 versus 18,000, and so on. So this affinity graph DB itself is it's a highly compacted proprietary database with the anchor being a brand. So for this brand and for the other brands that we have in our system, what are the metrics? And it's sort of stored in a way that it's first of all, as I said, it's highly compacted, and the query times are pretty responsive. I think we can get a response time in less than a second for any query that we make, because it's a lot of pre-processing that happens over here, and finally it's stored in this compact format, right? So that is what we do on the affinity graph database today. And then, of course, we have an API layer, which serves API consumers, which today are internal. There's another application that is not mentioned over here, And then, of course, we have the product which uses this API. Yes?
Questions, how do you match an individual across Facebook and Twitter? How do you know it's the same person?
We do not do that. We make a conscious decision because you would need some form of identifiable information or matching to be done. So we explicitly decided not to do that. And that's one of the reasons why, so it also sort of goes in line with the business where, not, so there's a, Jimmy Fallon, for example, is a good example. That's something we use. He is very popular on Twitter, but not that popular on Facebook. So you do have a pretty good balance of users associating themselves with brands in respective networks. So that covers a good percent. So we don't really spend too much time on matching users across networks.
As an expanded version of the answer, what we found, originally when we were doing it in the early days, people would ask, oh, that means you're duplicating the user. So the same John Doe is actually duplicated on all three networks, so you're going to triple counting at worst case. What happens is the average user, and when I say the average user, 90% of the population, or probably more. That is always the extreme cases of like 1-2% of the people who are very socially active and want to cross-post everywhere and whatnot. But the 90% of the audience does not have time to engage with a particular brand on more than one network. If I'm Kim Kardashian fan and I want to follow every gossip about her, then I do it on Twitter and I'll follow the gossip. I don't have time to go and then check out every post on Facebook as well. So, or if I'm a Toyota Prius lover, then I'll go actively comment on Facebook, but I may not be tweeting like crazy also at the same time. So what we found was the same John Doe, maybe in all three networks, but depending on the context, he actually goes and engages with different brands in different networks. And thereby, even though the consumer is duplicated, his affinities are not duplicated as much. And thereby, our triple counting, the double counting or duplication was not a major problem in our system.
So, one more question. The affinity graph database, is that at an individual user level or is that at a brand level?
No, so the affinity graph database itself is at a brand level. So as I said, if I can just go back 2 slides. Yeah, so this is the more compacted, very relevant version for us with respect to our applications at this point, while this is what you're talking about, it's at a user level. So we do have that also.
For the people with the data warehousing background in the audience, so what we ended up building in the architecture slide, so if you can show the architecture slide. What we ended up building is a custom OLAP cube with our own file system-based storage. There is no third-party off-the-shelf OLAP stuff that we could use because it would not support the kind of permutation combinations we had to do with real-time query response.
Okay, so yeah, I guess what I was getting close to was the API side of it is available for the internal consumers as well as the applications that we'll demo towards the later part of the session. I guess that covers it. Over to Shawn.
All right, so I'm just going to talk about a few of sort of the more interesting challenges in the data science side of things. So as we're trying to build models off of all this data, what are some of the things that we've had to work harder on? So how many of you guys have like done analytics or modeling on social media data before? A couple people. Even if you haven't, you probably can imagine that it's pretty messy data, right? And so, I thought I'd just give a few examples of why getting signal out of social data is hard. So I've worked also for some other social media analytics companies that are trying to do sort of broader things with social media data. And as somebody who's got a pretty deep experience in text analytics and natural language processing and stuff, it can be very frustrating to work with this kind of data. So I thought, so first of all, these are all examples from Twitter, which is maybe the most obvious way that it's noisy, like most obvious source of data where it's noisy. But If you are not used to Twitter and haven't looked at it much, you might look at this first example post and think, what in the world is that, right? It's not English. It's not like, it's confusing. I don't understand it. So if you actually kind of look at it, it's actually a thread. It's like four people responding to each other. So somebody said, "Who's up?" And then somebody said, like, CC'd the user called up and said, "Are you up?" And somebody did a sleepy laugh with some musical notes. And somebody else did a Wiz Khalifa laugh, which I had to look up. That's actually some meme. Like, so Wiz Khalifa is some rapper guy who has a very funny laugh. So apparently, like, if you look for hashtag WKL, that's actually the new LOL or whatever. Like, it's like a Wiz Khalifa laugh is a really big laugh, or like rolling on the floor laughing kind of thing. So if you're trying to like make some sense about what is this telling me about any of these people, like, it could be a very like hard problem to extract signal about. So all of these posts have the word up in it. And so Up is a movie, one of the brands that we track. And obviously this first post is not about the movie Up at all. It does mention a user called Up, an @Up, and also who is up. Somebody's asking, like, I woke up, anybody else awake? So here's another example. So there's all this colloquial stuff in Twitter. It's also very diffuse signal. Like, a lot of posts are just like, who's awake? Or like this person talking about eating ice cream on Ash Wednesday. Like, what does that really tell you about this user in terms of signal? Like, do I understand this person better having read this tweet, right? If you're trying to like model Lindy and what are her likes and dislikes and so forth. You know, not only is it not relevant to the movie Up, but like, so like you have to look at a lot of tweets like that by Lindy to start learning about her and what makes her tick, right? It's also very ambiguous. So here's something that mentions Up and movie, but it's actually talking about The Best of Me is a movie that's effed up. And so obviously just simple keywords and things aren't gonna help you too much about like finding relevant references to brands. It's also a lot of improper sort of English. So this tweet says, I, with a lowercase, cry so much with this movie for like 5 mins, literally. Better too late, T-O, than never, emoticon. So if you feed this through some NLP, the NLP will cry for 5 minutes, literally. It's just not going to work, right? The punctuation isn't there, the grammar is not there, the capitalization is not there. It just doesn't make sense, right? So you really have to develop something specific to this kind of data. It's also contextual. So here's an example, finally, of a movie that is a tweet about the movie Up. Wishing y'all a day full of love, that you'll have a lifetime of love like Carl and Ellie's. Happy Valentine's Day, #Up. Well, here's a #Up that is about the movie Up, but you actually have to know that Carl and Ellie are characters in the movie Up to really know that. So you have to have a lot of context about the things you're trying to find. And finally, it's graded or degreed. So here's another one about the movie Up. Up will always be the best movie. So we're looking for active, so think about it as a social net promoter kind of score. You can have a fan of a movie, or you can have an advocate for a movie, right? So there's a strength of that association. Are they actively promoting this brand? Are they just mentioning it? Are they liking it? Are they promoting it, right? So there's different, and what are the behaviors they have around, like, are they actively sharing it? Are they trying to get their friends to buy it? Or are they just saying, yeah, I went and saw the movie. It's like a different level of commitment, right? So here's some examples of why like the linguistics are hard. In addition, it's multi-channel, right? So we've got to look at Twitter and Facebook and Instagram and get some sort of common like base layer understanding from a modeling sense of like what does it mean to like have affinity expressed towards these brand in all these different networks in different ways. It's multilingual, so we've got lots of languages. Ambiguity is actually one of the biggest problems. So, you know, the movie Up is a good one, but there's, you know, scandal or castle. These are common words that, like, you have to, like, develop some pretty strong entity extraction stuff to figure out the right context. And then we've spent also time on, like, this sort of social net promoter concept, like how actively are these users engaging with these brands. Yeah, so any questions on that part of it?
With this rough data, what is your approach to cleaning, like,
Cleaning the data?
yeah, what are you using? I guess the natural language processing and what,
Right.
so what is your
Yeah, so we're storing, I mean, we have sort of multiple layers, as Mahesh was mentioning earlier, so a good practice is always store it in the raw form, right? Because you're going to develop better models over time and want to go back to like the source. But like our classifiers that are like extracting this stuff are, you know, just code that we've written, right? So you know, we're parsing stuff. We have sort of a different, like, a lot of our just ETL kinds of stuff is in Perl, but we use Python for a lot of the data science related stuff just because there's much better libraries and things. But both of them it's easy to parse JSON and things like that. And I'm actually talking a little bit about the process and tools and stuff we use here. So, yeah.
I have a question. So clearly, you probably encoded a large number of rules to go process this data,
Right.
and you continue to do so. Can you give us a feel for how many rules or how many new ones you need to create every week or every month?
Right. So it's not, I mean, in the general sense, it's rules, I guess, but it's not like a rules engine. Right. So I guess the way I think about it is we have about 40,000 brands that we track, and new ones are being, you know, there's new TV shows, there's new stuff. Like, Mahesh, what would you say the rate of additional new things?
Roughly about, in a month, we'd have about 10% increase in terms of the number of new ones that are coming up, new shows, new movies, put together, new brands.
Right. So, I mean, it's not a ton, right? But each one of those basically has a classifier, right? And so that classifier, you could think about it as it's like sort of a weighted set of rules or whatever. And so we typically don't refit them that often. But you know, obviously language changes all the time. And so, you know, obviously like the examples I gave of scandal, for example, like it didn't really exist until the different uses of it like changed, right, over time, at least in that context, right? And so it's something we are always having to put focus on.
So then when you add those brands into the system,
Yeah.
is that like a fairly manual process of some figuring out what will that classifying network or classifying rule set be at that point? Somebody
It
just
is
kinda
fairly, yeah.
Yes.
pretty- I see.
I mean, so the other thing here is like the architecture-wise, like this is where for Twitter specifically, obviously there's a huge volume, and so not only is it expensive computationally to process all Twitter data, but you just can't, like Twitter doesn't give access to people to do that, right? So GNIP and DataSift are sort of the two people that do have access to the full fire hose. So part of the classifier is basically deployed there, right? Because like you want to find like basically candidate tweets, right, from DataSift that you're actually going to like pull back, and then you do your second level classifier of like, okay, of those, like which ones are actually about this, right? So you kind of cast a little bit broader net, but part of the like it is manual because like you have to go configure your data sift to like bring you the right stuff, and then you have your classifier as a second step. So you could think about the classifier kind of encompassing data sift and our own rules, like in a meta sense. So from a modeling perspective, there's an overwhelming number of ways to approach these problems, right? There's like a gazillion algorithms out there. There's a gazillion ways to think about it. And so in terms of sort of the challenges of like to how to apply data science to this particular problem, that's a big one. With a relatively small team and relatively limited sort of budget and time and money, like how do you make progress quickly? And so I thought I'd talk a little bit about how we approach that. So first of all, like we're basically standing on the shoulders of giants, or like everybody here, the community, right? So when we're looking at problems, we start with literature surveys, like how have other people done this? We use our networking events like this one to like talk to other people about how they've done things like this before. And so we get a general idea about like what are the kind of the similar approaches to similar problems that other people have applied successfully. Then we use a lot of open source, right? So it could be a full-time job for all of us here to keep track of all the new like open source software and data science is being released constantly, which is great. But it can also be like a lot of noise to wade through too. And so that's part of the networking and conferences and stuff too. But I thought I'd mention a few of the ones we're using here. And so a lot of times we'll start with a very quick prototype of something using an off-the-shelf algorithm or approach, right? And so depending on the problem, like if it's more of just like kind of a classical statistical model, we might use R, and a couple of the packages we use a lot are GBM and GLMNet. If it's a little bit more lower level, like where we're creating, we're integrating with doing a lot of data processing, like text is a place where we need to do a lot of data feature engineering. The TM package in R is not great. It's not too scalable. So Python with the scikit-learn framework is a great place to, there's a lot of good algorithms in there. We use that a lot. You can also use at the text layer, like NLTK and Pattern are good libraries for Python. And GenSim is a good package for like topic models. If you're doing like streaming stuff, like your online learning, Valpo Rabbit is a good package to start with. So does anybody else want to share anything they love or questions about any of these tools? Okay, so generally though, like, you might read some paper about a related problem, you might pick a package out of scikit-learn or out of R and like do a quick prototype. It basically will give you confidence that it's going to work, but the devil is always in the details, right? And so a lot of times we get the breakthroughs by adapting, using the constraints to our problem, right? So like, well, for our domain, like these are the important adjustments we're going to make to the algorithm. And so sometimes we'll just keep using an open source version, but a lot of times we'll make some tweaks, like optimize it for our problem, our domain, our industry. And a lot of our code is pretty, we have a lot of software engineers, so we tend to like do it ourselves a lot. Let's see, so the other thing I think is important is cadence. So, a lot of like, if you go work for Microsoft Research or something, you might be closer to grad school where you're working for like, years on the same kind of problem, same domain of problem. I mean, we're also working for years on the same broad domain as well, but generally we try to be extremely pragmatic in our research. So, we don't have much goal to publish, right? We're really just most of the time not doing original research, but just adapting other people's research to our problems. And so we find like a 6-week cadence is a pretty good one for applied research. So we try to, quarterly goals and like don't spend more than 6 weeks till you have a prototype on something, and get quick feedback basically on what's working. A couple other big problems in this space are, when you're doing supervised learning, it's always a challenge to get the right data. And so, this is a case where creative use of data is like kind of one of the key hats of sort of the data scientist, right? I mean, you can think about it in other domains, like, credit scores, like FICO scores, for example, are developed off some labeled data, right? Like people who apply for loans and like they pay them or not, right? So you've got this good supervised feedback loop you can train on, but then people use it for all kinds of things, right? So you're generalizing from that, saying like, well, if somebody's a good credit risk, they'll probably be a good renter too, right? Like if you're a landlord, you might run somebody's credit score and say, well, it gives me some confidence this person might be a good tenant. If they also have a good credit score, it uses common things like that. So in some ways, that's a little bit like what we're doing. We're saying we're modeling in one domain, like how social media interactions and behaviors work, and we're applying it to other domains. And so it's always a challenge to keep, to cross that chasm of like, where does it generalize well and where doesn't it? Any other questions, comments on that? Okay. The last thing I was going to talk about, which is sort of a specific problem to us, is kind of deployment of models. So for those of you that work in data science and are fitting models, deployment is always an interesting, there's lots of best practices and stuff around deploying models, even if it's in your own, working with your own engineering team or integrating it into your own product, there's lots of gotchas, right? However, for us, we are working with a lot of DSPs. So we have some uses of our models internally and within our own application that we host, but we also deploy it on various ad networks. And so most of these guys, like, we have a very kind of hands-off relationship with, right? Like, we don't have access to their engineering group or whatever. So most of them have some kind of rules engine that they have, right? And so we've spent a lot of time working on the problem of, we have some statistical model, like this is just like a naive Bayes like representation, but it's representative of lots of different, like, sort of, different models have different representations, but it's always going to be some more complicated thing than a set of rules for a rules engine, right? And so one of the big things we've worked on is some optimization algorithms that we've developed to, like, basically take some complicated model expression and then try to preserve as much of that signal as we can in sort of a rule system. In fact, some of these rule systems are not very sophisticated. They only support, like, disjunction, for example, which you can't be very expressive in your models with just disjunction, right? But you can still do something. And so, some of them have plugins, some of them do conjunctions as well, some of them can do weighted expressions. So we kind of adapt, like, we have a kind of a model rewrite rule at the end, right, to, like, adapt it to the environment that we're deploying it in. All right. Any other questions on I mean, I didn't get into a lot of details on specific models, but I just thought I'd share with like some of the things we've spent time on, some of the challenges. And this is the end of my section. So anybody have questions for me?
Do you try simple regression model instead of?
Uh-huh. Yeah, so we're actually not using naive Bayes. I just thought the formula was appropriate for the slide. We're using a lot of, we are always trying lots of different kinds of models. We are using Bayesian networks in a number of cases. Like one of the advantages of that is we can put in some prior knowledge into those networks where we don't always have data for everything. But for our supervised learning kinds of techniques, boosted trees is we have lots of luck with, like everybody else, or tree ensembles in general, random forests, those kinds of things. Because of the constraints we have in some of the deployment environments, we have tried just sort of optimization approaches. Yeah, I mean, obviously we're playing with like deep learning and stuff like everybody else. So, I mean, we're just adapting the right models to the, trying lots of things all the time. And we're using a mixture of different kind of models in the end, but.
I guess how often do you actually tune your model? Do you actually try it out actually? Is that the
It's
case,
pretty
or are you
constant,
more,
yeah.
pragmatic in a sense, you build a model, kind of deploy it then later on. I mean, what is your?
No, I mean, yeah, it's still active research, right? So we don't think we've got to like, so I mean, we deploy models to a lot of these DSPs monthly. So, I mean, we're always going to refit the models every month just to get the best performance, but we might get to a mode someday where we basically have the same structure of the model and we're just updating the weights. But right now we're still playing with different structures pretty often just to try to get better.
So how much specialization of the models do you have per brand? Is it like, do you have like a generalized model, like you said, and kind of you're tuning and doing the supervised learning to figure out the weights? Or do you have like,
Right.
do you have like highly tuned kind of model? Like, how intensive is that kind of process?
Right. Well, so we're using basically the same structure for the models for the entity extraction problem, like the brand identification problem. Actually, where we're spending more time now is like in the actual like, so we do, I mean, you could think about kind of a big application of our technology is sort of in the cookie marketplaces. And so, just like an Amazon, people who bought this also bought this kind of thing. Or you might think about a more sophisticated Netflix kind of recommender system where like, I know you like these 10 movies, so you'll probably like this 11th, 12th one too. It's like we're doing that kind of at the cookie level, right? So people have expressed interest in these things, so what else are they probably interested in? And that's the models that I'm mostly talking about when I'm saying we're still refining those a lot.
This question came from a comment you made about the Lady Gaga problem. Looking at affinity baskets for retailers, banana was the equivalent of Lady Gaga.
Yeah.
In every basket.
Right.
So my question is, are you learning from the brick and mortar affinity type algorithms to apply to any part of your affinity graphs to see if there is affinity between what you learn from the brick and mortar RFM world to what you're doing with your brands?
I think so. In terms of techniques, I think we're borrowing a lot of the same ideas. Like originally, in fact, we were kind of maybe borrowing more heavily from that space, and we've kind of refined it since. In terms of data, not so far. Like we've talked about pulling in, like trying to marry some of the social data with purchase data, right? If we could source it. No, we're not doing that so far. Something we talked about, we continue to talk about.
The other question is, how much of geography plays a role in either your data or your algorithm?
Yeah. I mean, sure.
So one nice thing about Affinity is it's actually very self-selecting. Sorry. For global brands, obviously you're going to have, like say Coke is a global brand, so you're going to have fans from all over the world. But many brands, 95% of the brands are very local. I'm saying local in the sense of not like Austin, but it's like US only or like regional only and so on. Thereby, because it's very active engagement, it's not like just casually like going away for the next 5 years and not carrying over the brand, you tend to have that recency element to it. And also we have algorithms that weight different behaviors differently. Like if you're actively commenting on the page or you're posting photos repeatedly, then we actually weigh you higher or score you higher. So because of all those things, you tend to have recency and frequency kind of modeled already. What happens is the geolocation is self-selecting. So we have later on in the demo in the next 5 minutes, I'll probably show you, for example, local radio station. Obviously has a very high locality to it. Because it's a local radio station, you're going to see that all their audience is primarily Austin audiences. It's a local radio station. There are certain exceptions. So if you are from the radio world, there's a station called KEXP, which is very popular. It's LA based, but it's very popular among the indie crowd nationwide, right? So you're actually going to get some exceptions like that. But most of them, the brand's audience self-selects. They come only from the geography. So, so thereby we do not have to apply as rigorous kind of, we have to separate out the location and all that. But that said, for the global brands, that is a problem. So global brands like Coke, for example. So today our geographical segmentation is at the country level. So we actually segment by the US versus international fans and so on. So you can actually analyze only the Coke US fans. Later on the product, I'll show you how we actually go down to the DMA level and specific geos.
Right. It's not a big feature of our models, but it's an application, I guess, right? Like you can say, the affinities changed by geography. It's an insight, right? So on the modeling side, I'd say that's true.
You don't use any geography from your Twitter accounts or Facebook accounts, or even the contextual geography in the tweet itself.
No, we do use the location. So Mahesh can answer that.
Yeah, so contextual geography from the tweets, yes, we don't use them explicitly. But there is, as you said, at the DMA level and the country level, is from the tweets, there is information about, at least for about 20% of the tweets that we get, there is information about the location. So we do definitely use that.
One other question, quick question. What query language do you use for your graph database?
It's
Proprietary.
It's proprietary. It's actually SQL based, so we have a SQL interface.
Okay.
But then the work is done by a mix of Perl and C to extract things out fast.
So how we got started was we took the Postgres database, ripped apart, threw away the database engine, and then put our own database engine.
Right.
Use the Postgres SQL wrapper as a convenience mechanism, so other modules can call.
Got it. So you could use the same queries on your MySQL.
Right.
All right.
So I'm going to wrap it up with the kind of a talk about how this data is all presented, and then get through a couple of minutes of demo. So the visualization part, again, I want to give you a progression of where we had come from. So this is a tabular interface that we have in the product. Just to walk you through, so this is for the brand Snapple, and then you're actually seeing what are the affinities Snapple fans have for TV, and then you can see here Young and Hungry, an ABC family show, T.I. in Tiny, Love and Hip Hop Atlanta, Love and Hip Hop, and so on. So you can actually see what are all the TV shows they're into. And we talked about that kind of the forward affinity and reciprocal affinity. And there is also a statistically significant score, 100 being an average. We actually compute how statistically significant is the liking for Snapple fans to Young and Hungry. You can actually see that 100 is average, which means that it's 4.7 times more than the average population. Then there's the growth period. So there's January 28th to February 4th. During that period, how it's actually changing. And then we bake all this in to come up with that percentile score. MEQ, it's actually a historical term that we use called mutual engagement quotient. So it's a percentile score. It's like a page rank that we use to sort everything in our system. So this is one interface. The other interface that we have, it's probably hard to see because of the black background. So this is actually a more visual interface where our customers can actually see how things change over time. So if you're Snapple, then again, this is actually a demo that is available on our website, so you guys can actually go play around with it. You can select a brand and then hit the play button here, and it'll show you which brands are actually going towards Snapple or moving away from Snapple. The whole idea here is like it's roughly a galaxy metaphor. So Snapple is, let's say, the center of the universe, and who's getting attracted to Snapple and who's getting repelled by Snapple. And then you essentially use that as a intuitive way to understand, okay, I got to actually go after young and hungry fans to leverage the momentum that they have building affinity towards Snapple. So those are the two interfaces. So what I am going to now switch over to is a demo of both of those versions. Again, the way you access this is, are we out of time?
We're good.
Okay, all right.
About 3 more minutes.
Okay. So you can go to affinityanswers.com and then like you can click on the planners and buyers page, and then if you click on the launch tool, then it will launch the tool for you. So this is actually a logged in version. The public version will show you the top 2 affinities. So let me get into the presentation mode. So I had Snapple already loaded up here. So you can actually see here over time how the affinities are changing. So just by looking at it, you know that Foster's is not a good audience for you, because they're moving away from Snapple. And Young and Hungry, Love and Hip Hop Atlanta are good audiences for you. So you can actually segment by a bunch of things. You can actually say, I only want ABC family shows. So you can actually see which ABC family, you know that the Fosters they don't like, but okay, the Young and Hungry they like, what else do they like? Okay, ABC Family's 25 Days of Christmas. So those are shows that I can actually use. Or I can actually look at like just broadcast networks. Just give me ABC, NBC kind of thing. What are the broadcast shows that are good fit for me? It's actually refining the whole demographic targeting that you would have used as a media planner to decide on, say, I should be buying Family Guy, and then saying, okay, Family Guy is even better fit on receptivity, which is the affinity side also. Thereby you can actually see here, like if you play it around. The reason the growth numbers are smaller is these are big shows, which means they're elephants. So they have to move slower. They're bigger audiences. So they'll not move as fast as some of the smaller shows are. If you wanted to see like, okay, what is the recommendation you can give me, you can actually export this, just kind of a quick and dirty media plan. So let me show you what the spreadsheet looks like. So you would actually get a dump of what are the TV shows, and thereby this is almost like your media recommendation. It's like the Google Ad Planner version. This is, let's say, for lack of a better word, Affinity Ad Planner. What keywords should I be buying for Affinity? In AdSense, in Facebook, in Twitter, many of these things. In fact, many of our clients use this kind of recommendation to buy heavily on Facebook and Twitter, and now soon in Instagram as well. Okay, so that is the one version of the tool. The table version of the tool is kind of looking at the same data but in a tabular way. So thereby you can actually do kind of slicing and dicing in different ways. So you can look at which TV shows they are into. You can actually look at what other brands, people who, oops, sorry, I haven't logged in. So you can actually see people who actually drink Snapple, what else are they interested in? Looks like they actually take some Tic Tacs, then eat at Wendy's, drink Fuse, in addition to Snapple, Baskin Robbins, have ice cream at Baskin Robbins. So those are the kind of, just you get the rough top level idea. And it gets very, very granular. So you can actually say, okay, I'm going to actually go in there and then say what kind of paper towels that Snapple fans are interested in. So you can see Cottonelle is the top brand for among Snapple fans. You can also do, we actually do non-profits as well. So let me see, organizations, yeah. So you can actually see like if you wanted to do what kind of causes do they stand for and so on. So you can see American Kennel Club, Box Tops for Education. So you get into very specific non-profits that they stand for. March of Dimes. So this can be used obviously for like any non-profit sponsorships that the brand wants to do. And then you can also see the digital affinities. So you can see what kind of websites do they go to. For example, Hello Serial Lovers, Pandora, iHeart Radio, and so on. You can also see what kind of, even up to the level of, for example, what YouTube channels are they watching. Yo Mama, Shut Up Cartoons, Shane Dawson. So they may not be obvious, that is the whole point, is to be able to use Affinity to surface those things. So you can actually do very targeted YouTube ad placements there. And I talked about this is the local. This is obviously Snapple is a kind of a national brand, but you can actually see which local radio stations and TV stations their fans are actually coming from. So this is a TV station, so you can actually go all local. It actually has not just TV stations, it has local venues as well. And if they are in the top 10, no, this is just radio stations. So you can actually see they are into WWPR, Power 106 in New York, it's a hip hop station. So you can see which stations they listen to. So again, the counter use of this is Power 106 can actually go, you can go into Power 106 if I am the radio station ad sales guy and then say what brand should I be pitching for advertising on my station. So you can actually see which brands. So I had the non-profit thing, so let me actually remove that and then you'll see what brands they are into. So not surprisingly, there's a bunch of record labels there on top, but you can start to see here Poland Spring, Golden Crust, and so on. Some of them may have had a recent relationship with the media company here, and that's why it's actually appearing high on the list. Yeah, so just going back to Snapple. Just want to kind of do a quick walkthrough and then we'll wrap it up. So on the other tabs, this happen. Okay, so so we were looking at brands before for Snapple audience. You can also look at like what music do Snapple fans really engage with. R&B and hip hop and soul. So let's see what kind of audiences they're interested in and what kind of apps and games they play. So we have like mobile apps, you can see Square and Toca Boca. Yeah, so to be able to get like where should you be placing ads and what movies and books they're interested in. Haunted house, ride along. What sports teams they're interested in. Knicks, they're Knicks fans. So to be able to know Snapple versus that. There may be a sponsorship also. A Snapple might have sponsored something on the Knicks. These are it's a celebrity. It's actually I think it's an MTV reality show personality, JWoww, and so on. So you get a kind of a rough idea. So this is essentially all these affinities is actually driving the segment selection in our activation side of the house. To be able to actually say, okay, now I got to be able to take using TV as an example, the way I would extend the reach for Snapple audience is to go after young and hungry audience, TI and tiny audience, to be able to actually expand the reach. Yes, that summarizes it. Any questions? Great. Thank you guys all for coming. We're available if you guys want to talk to.